If you attended the viewing last night of Chasing Coral, you have a good introduction to what is happening at this workshop. So Mark Eakin, who was not featured in the film, but in the film, you have a good idea of his interests and of his professional life. And I'm just going to tell you a little bit more before he gives us a follow-up to that film. Or maybe I should call it an update. So Mark is a retired oceanographer now, and he was with the National Oceanic and Atmospheric Administration for 30 years. He is also a contributing author to, or a reviewer to multiple interpanel on climate change reports. He was the chief science advisor for that film that we saw last night, Chasing Coral, and has testified before the U.S. Congress. He is a ruling elder serving at Warner Memorial Presbyterian Church in Kensington, Maryland, and is in the National Capital Presbytery, and he is also on the steering committee of Presbyterians for Earth Care. You know, I think Mark deserves a welcome from us.
Thank you, Jane. Yeah, I have the affiliation of being retired from NOAA up on the screen for a reason, and that's because a lot of what you're going to be seeing here, a lot of the work that's on there is the work of NOAA Coral Reef Watch, and if I ever say we, think of it as they, because, you know, after a long time running an organization, it's hard to get out of the habit. But what I'll do is I'll give you an update from of what's happened since the film, give you an idea of what's going on, and for those who have not yet seen the film, I'm going to hit on a few of the very important points, and I'll say if you haven't seen the film yet, go watch it, and we'll be discussing how you can see that in the presentation. So, Casey? So first, for those who are watching it or remember, question, raise your hand. Is a coral an animal, a vegetable, or mineral? Let's go first. Animal, raise your hand. Vegetable? Mineral? Okay, we got one over here who raised her hand 3 times, and the answer is, Casey? All of the above. Because corals are animals, they have microscopic plants living inside their tissues. That is the reason that they're able to live off of sunlight, and that's what allows them to build the great skeletons that they build. Next. What you're looking at here is one of the places actually that's featured in the film in American Samoa. Fuanamofuti is or flower pot reef. What you're looking at are 2 shots of the same spot, one in December of 2014 and the other in February of 2015. The left side, the coral was perfectly healthy, the right side severely bleached. It's a very visual, stunning image of what happens when this bleaching occurs. Next. And what's going on is those microscopic algae that are found inside the tissue of the corals are literally being ejected from the coral. The coral rips their guts out and spits them out into the water. They don't eat them. They don't even get the advantage of eating the algae. They're just spitting them out. And longer story, different talk gets into the physiology of why this happens, but it's a result of stress. It's a result of the high heat stress that's being seen on these reefs as a result of climate change. And so what you're seeing is, in this close-up of a different kind of coral, you're seeing some of the corals like that one on the left, where you're seeing a little bit of the algae still in the tissues, and then over to the right you can see in those tentacles that the algae is basically gone. There's actually a little tiny bit that stays in, and that's very important to recovery, but it's a very, very tiny amount that's left. So the reason this is happening, as I say, is the result of climate change. This animation, which is a version of something that Ed Hawkins developed and then has been expanded on by NASA, is showing the monthly average global temperatures every month of every year. We started back in the early part of the 20th century, and we're stepping forward. And what you're seeing is it was pretty boring. It's just, you're going around and things change, but And there's some little ups and downs, but there's not a whole lot that you've seen that's been different throughout most of the time period we've been looping this video. But now in the 70s, we start getting to a change, and you'll start to notice that we start going outside the bounds of where those were previously, and farther and farther. And now that we're getting into the 2000s, we're starting to reach outside that envelope completely, even touching on the 1 degree centigrade warming and extending beyond it in 2016 and even more recently. So you're looking, if we spin this around on its side, oops, well, it didn't quite make it all the way to its side. There we go. What you're looking at is dramatically warmer temperatures in recent decades than you had in the early part of the record. And in the discussion we were having last night about climate change and the Matthew 25 program, the discussion came up that, yeah, there is natural variability that happens in climate. What we're seeing in these recent decades is a dramatic change. So we'll go to that is average surface global. I believe that record is air temperature. It may be air and ocean combined. I'd have to go in and check and see which one they used in that. The results are the same either way. I'm pretty sure that's global surface air temperature reconstruction. I've been using this diagram, or shall I say, repeated iterations of this for about 20 years. It's one that that NOAA puts out. Looking at recent years, and what has really changed in the last decade is all of a sudden now the 10 warmest years on record, look at all of the 10 warmest years on record are since 2010. It used to be there were some stragglers back in 98, the really big El Nino then. It's moved out of the top 10 now. So we've been seeing in recent years, it's not a linear trend because there's variability year to year. Some years are warmer than others, but we've been getting warmer and warmer, and the last decade is absolutely the warmest decade that we've ever experienced on Earth. And what you're looking at in an interesting one in black is that black line is 2023. That one's going part of the way through the year and stopping, and that's the warming that's going on right now in 2019. We've transitioned from La Nina conditions into an El Nino condition, and that leads to warmer conditions. You have warmer years in El Nino years. But even when we started under La Nina conditions, it was among the top 10 warmest years on record when we started the year. So we've seen a dramatic change. This is the shift that we've happened, and this is what the corals are feeling. They're being pushed outside their comfort zone to temperatures they haven't seen before. This is all the result of the impact that humans are having. Models that have been done that have looked at the natural variability component of this is tiny, and in many cases would actually are trying to cool the climate, and we're overwhelming all of those. The biggest part is atmospheric carbon dioxide record from all of our burning of fossil fuels, production of cement, deforestation, various activities that humans do. And this record from Mauna Loa Observatory, the longest record we have, you can see it going up. And this year, like every year, despite all the things that are being done around the world to try and reduce CO2 emissions, it's still gone up another 2 parts per million, just like it has for the last several decades. Now, what is done at Coral Reef Watch and leads to what we're going to be talking about with the corals is to use satellites to look at the sea surface temperatures that cause coral bleaching. And so what you're looking at are 2 different kinds of satellites that are used in the data sets. The geostationary satellites are the ones you're used to seeing most of the time on your weather channel. These are the ones that stay in place over one spot of the Earth, and you can watch a hurricane moving across, for example. And then because those don't cover the whole world completely, and also to be able to standardize across, they're also using these polar orbiting satellites to cover the entire globe and get the polar regions and things of that sort. So it's a combination of 2 different sets of satellites from multiple countries around the world being combined into a single data set. And that basic data set is this 5-kilometer resolution sea surface temperature. Every bit of ocean around the world, and even big enough lakes and inland waters, are picked up by this, getting a measurement of sea surface temperatures. And what they do at Coral Reef Watch, they can compare those temperatures against the normal conditions at a given time of the year and against the temperatures that cause stress for corals. And what you'll be seeing next are the images are these bleaching alert area images. And these go all the way through to creating the degree heating weak products that are really a good predictor of coral bleaching, and then breaks it down into simple things of alert levels like we're used to for hurricanes and things of that sort. So anything blue is no stress, anything yellow is a bleaching watch. Then you get into the bleaching warning, alert level 1 and alert level 2. Alert level 1 is where you see significant bleaching going on. Alert level 2 is widespread bleaching, and you start to see corals dying. And in fact, this is what we saw from 2014 to 2017. This is a time lapse going through that period, and this is the period captured in part in the film Chasing Coral. Now, the filming of that really ended in 2016. This event that went on for 3 years went through into 2017. And so what you're seeing is the bouncing back and forth from the northern hemisphere to the southern hemisphere and back again, like a sort of a perverse game of tennis. As the heating went back and forth and was hitting coral reefs around the world continuously for 3 years. This is the first time that this has ever been seen. Bleaching events in the past were one and done. It was a single season of bleaching that would happen in a location, and then the corals would get a break. Here we had bleaching going on repeatedly, and in this next slide, what you're going to see is if you combine all of that together into one image, that's the heating around the globe. Almost the entire globe was hit with the kind of heat stress that causes bleaching or death in corals. There actually are a couple of blue pixels in there. I will promise you, you will not see them. They are there. But you see how warm it was during that 3-year period where we had a sort of a part of an El Nino came into a full El Nino, came into a 2-year-long El Nino, this long cycle that then dropped out afterwards. And we had it was the longest bleaching event ever. A lot of areas, over half of the areas were bleached twice, many of them 2 years in a row. The Great Barrier Reef, for example, and we'll talk about that in just a second, saw bleaching 2 years in a row. So even those corals that survive are getting hit again the following year. And there was a period in Guam where they were hit with bleaching 4 out of 5 years in a row. And it was just devastating to their reefs. So some of what was in the film Chasing Coral talked about the mortality that happened on coral reefs in the Great Barrier Reef. You're looking at the northeast coast of Australia here, and those really dark areas are where the severe mortality happened. This is not the satellite images of the heat stress I've been showing. These are actually measurements of the bleaching severity that was seen as a result, and the two correspond amazingly well. But if we look at the next slide, what you see is that this was one of those examples in Australia where they had severe bleaching 2 years in a row. 29% of the corals in the Great Barrier Reef lost in 2016 and another 22% in 2017. That was actually happening starting right as we were premiering the film at Sundance Film Festival. And it was just, we were like, it was great. We've got this film, we're telling people, and it's bleaching again back in Australia. What is going on? So it was really a traumatic event to those scientists and filmmakers who were involved in the film, as well as people all around the world dealing with this issue. So that leads to the film. As I said, if you haven't seen it, see it. It's available on Netflix in full resolution and even 4K high def. You can also, if you don't have Netflix or someone else's Netflix account password, this was a big joke when we were together with the Netflix people. I mean, they just, they know how it was working. But what Netflix did a couple of years ago on Earth Day was they took 10 of their films and made them available for free on Netflix's YouTube channel. So if you don't have access to Netflix, go into YouTube, search for Chasing Coral, and you'll find two things there, the trailer and the full movie. So it's a great place to see it. Now, let's talk about the future, or actually the now. What's going on right now? You're looking at a forecast. These are probabilities, and these funny alphabetical things are at the bottom are the way that climatologists do multi-season forecasts. So that's August, September, October, September, October, November. These are floating 3-month periods. And you're looking at the probability of either El Nino, La Nina, or neutral conditions. If you go to the next slide, yeah, the magic 8 ball is saying yes, definitely. This is something that, it's hard to get forecasters to say 100% probability. Guess what? We're in it. We're going to be in it. And the probability of this being a big El Nino has been in place for several months now. We're looking at definite El Nino conditions, warming that's going on, and we'll look in the next chart showing sort of what this has done in terms of heat stress. That is September 19th, so the day before the conference started, satellite images of heat stress alert levels for coral reefs around the globe. Right now there's severe bleaching going on across the Caribbean and the Eastern Pacific. That's how these events tend to start. If you look at the Caribbean, especially the northern Caribbean, it's just all dark, deep red. The southern Caribbean actually isn't at its warmest time of the year. That's coming in the next couple of months. So it's going to just be continuing. There's been a lot in the news about this. You may have seen articles. This is a picture of bleaching going on in the Caribbean. There's been a lot of it that's been hitting. And Florida has had high heat stress that's gone on that is just, when I say unprecedented, there's no question. The top is the variability in temperatures on the reefs in the Florida Keys. The black line, again, is current temperatures. You saw it went above anything that had ever been seen for a couple of periods. Down below that little chart, those are all of the past heat stress events measured in terms of degree heating weeks and the alert level colors. And look at what happened this year in the Florida Keys. It was so bad that the efforts that are going on for restoration of corals, they were going out to the nurseries and the corals that have been planted on reefs, pulling them out of the water, taking them to aquaria on land where they could keep them cool. That's the severity of what we've been seeing this year in the Great Barrier Reef, and a lot of that was seen back in 2016 and other places. Fiji, I was talking with folks in Fiji and some of their inshore reefs when the heat in 2016 was coming in, the corals weren't bleaching. They just died. They just, you went out and it was getting hot, the corals started to look a little pale, and the next day you came out and tissue was just floating off of them. And we were seeing that in the Florida Keys this year as well. This is the kind of thing we've been seeing. The forecast. This is using climate models to look at the coming months, and what you're seeing, as I said, the southern Caribbean is going to be bleaching, and there'll be continued bleaching on the west coast of the Americas and the eastern tropical Pacific. And there you're seeing heating that's likely to happen back over in the western Pacific as this event continues through time. Is it going to be a multi-year El Nino like the last one? We don't have models that really are good at predicting that far in advance, but if I were a betting man, I'd be betting in favor of it, and that's unfortunate. We may be seeing another of those multi-year events kicking in now. And it's not just coral reefs, and so let's think a little more broadly. This is sea surface temperature, so this is no longer looking at just the corals. These are anomalous sea surface temperature where it's hotter than normal, and you can see the El Nino, the high temperatures that normally are in the western Pacific this time of year. The heat has been crunched up against the eastern part of the Pacific Ocean, and that then causes what are called atmospheric teleconnections, heating up the air that then heats up the water farther over, heating up the Caribbean, heating up the North Atlantic, causing really severe warm conditions in the North Atlantic. And I'm going to stick with the oceans for most of the talk, but I just was caught by this. This is the heat of the anomalous temperatures that are going on this week in Brazil. Up in the Brazilian forest, the high temperature a few days ago was in the range of about 110 to 115 degrees. That seems normal for summer, right? It's not summer. That's winter. That's winter. We've been seeing in the parts of the southern hemisphere some of the hottest winter temperatures have been seen, and even setting some annual records in places for the hottest temperature of the year in winter. But going back to the ocean, again, it's not just what's going on coral reefs. There are all kinds of ecosystems being affected from these marine heat waves that have been going on around the world. Shellfish population collapses in the Mediterranean and the northeast Pacific, along our Pacific Northwest coasts, along the North Pacific. There are algae beds, great kelp forests that have just vanished. Tasmania, Western Australia, there are kelp forests that have just gone from the heat, just dying in place. Seagrass meadows that have been dying in large quantities, diseases coming in, wiping them out. Marine mammals, seabirds, fish stocks. Anytime we get these large heat stress situations, it's causing major impacts that are affecting not only the ecosystems, but of course the people who depend on them. In the case of coral reefs, somewhere between 500 million and 1 billion people rely on coral reefs for their food, for their income, for their livelihoods. And when coral reefs are bleaching and fish are dying and leaving, it's affecting a lot of people around the world, especially people, the subsistence fishers and local people who are very much affected by this and are in the countries that are doing the least in terms of putting CO2 into the atmosphere. If we look at the poles, many of you have heard about what's been going on in the North, in the Arctic Ocean and the loss of sea ice. This is a graph, and you can see the flat line, the mean or average amount of sea ice going flat across at about 8.75 million kilometers square of ice. And you can see the trend, the huge trend of the loss of sea ice that's been going on over the last couple of decades. And it's just been continuing. We're losing more and more ice, and as we lose ice, we lose old ice, so a lot of it's thin ice, so it's going even faster. The southern hemisphere has always been a little confusing. Why is it not responding? And there are a lot of reasons for that. And you can see that if you look at the trend and the mean, they're just about the same. But right now, there's something going on. Look over in the lower right. That's this year. There's been over a 15% drop in sea ice this year from the levels that we've had previously. The Antarctic has started responding. And that's going to be big. And I can tell you a lot of the scientists who are involved in glaciology and sea ice work in Antarctica have been scratching their heads trying to figure out just why it's dropped so fast in 1 year. And stay tuned. I don't have an answer for you on that one, except, of course, it's getting warmer. So all of this has happened with just 1 degree C of warming. You hear these being tossed out about 1 degree, and 1 degree doesn't seem like much. That's a little less than 2 degrees Fahrenheit of warming. And what's a degree, right? It's no big deal. But you're talking about in terms of the global average temperature, that 1 degree is actually a lot. And if you look at what has been discussed in things like the Intergovernmental Panel on Climate Change and the UN Framework Convention on Climate Change talks that go on, it's really they're talking about 2 different trajectories, warming by 1.5 degrees total or 2 degrees total. And so to put it in perspective, all these things we're seeing now, that's at 1 degree. And we're talking about another 50% more warming or 100% more warming are the targets we're talking about. So just think about the things that are happening now and imagine what happens when you double the amount of heat. This is a complicated diagram. I'm not going to go into the details of it, but what it's talking about is the emissions that are needed to get to targets. If you look at that historical diagram, that's how emissions have been rising, how we've been continuing to put more CO2 and methane into the atmosphere over the years. And the little red wedge at the end is the trajectory based on the reductions that countries have promised. And that's that little bit up there in red. And those 2 big slopes going down there, those are what we have to do globally to either stay at 1.5 or 2 degrees. We're talking about complete changes in our economies and a major reduction to eventual elimination of fossil fuel burning. That's the only way that we can get to those. And so we're looking at something big in the future. So, you know, I realize this has been a bit of a gloomy talk to this point. So let's start looking at what we can do in the future, because it's really important to think about the fact that we do have this important trajectory ahead of us, and there are things that we all need to be doing for coral reefs and for the rest of the world and the societies living in it. Good news. There's been a lot of national and global action. There needs to be a lot more. We as PEC and as individuals and in our churches need to be pushing our governments to be doing more. There are some countries that are taking major steps. France, for example, is just on the verge of shutting down the last of their coal power plants since this announcement. There are a number of countries that are getting rid of them. There are a number of countries who have reached the point now that their renewable energy is larger than their fossil fuel energy. And this has been a tremendous move. And we're making some moves in this country, but we need to be accelerating that. And that's something that we all need to be doing. So number one, if we want these changes to happen, that's advocacy. We all need to be speaking up about this and pushing to make sure that these changes are happening. Number two is we can start looking at individual actions. So lower left, that's Jeff Orlowski, who you saw in Chasing Coral, the director, producer of the film, and myself when I literally, it was so funny, I was doing a screening with him in College Park, Maryland, and the night before that arrived in the mail the license plate Chasing Coral that I had ordered for our Nissan Leaf. That license plate's no longer on the Leaf. Gene Brown's driving that Leaf. Is now on the Mustang Mach-E that we have in the picture down below. We've gone all electric, and I'll show you our other one next, but it's not just driving electric, it's also using mass transit, using bicycles, using alternative means of transportation. If you've got a good transit system, a lot of the train systems are all electric. A lot of buses are now switching their fleets over to electric, so there are great moves in that direction, things we can do in our choices. It's not just cars. Yeah, we've got that electric pickup truck, and that's the travel trailer that we pulled from Maryland to California and back. So if someone tells you that electric pickup trucks can't tow, how far you need to go? You know, we made it from ocean to ocean. Don't know why you need a lot more than that. But more importantly than individuals' vehicles are the tradesmen who are using those pickup trucks on a daily basis. The Amazon and UPS and FedEx and all the companies that are going to electric delivery vans, the work vehicles, the electric vans, that on the right is a Ford E-Transit. Those vehicles are used every single day, day in, day out driving, and that's where you really make a difference. Because those vehicles are going to be reducing emissions tremendously from highly emitting vehicles. So businesses can make a big impact on this by taking their fleets electric in those situations where it makes sense at this point. The other, you may have heard of something called carbon capture and storage. There are these systems that are being developed. This, you know, that's an artist depiction of a scaled up one. There's some of these facilities that are in place already going. What people don't realize is all of our pathways to get to 1.5 and 2 degrees require that we do these things. It's not that we're doing these things so we can continue to burn gasoline. That's the wrong way to do it. If we're continuing to burn fossil fuels and then pulling it out of the atmosphere, it's really tough to get the job done. What we need to be doing is decarbonizing our system as fast as we can and using things like this to get the last bit out and reduce the CO2 from places where we can't manage to get it out as quickly as we need to. These are expensive, these are hard to do. There's not a good economic model for keeping these running yet. That's where carbon taxes or fee and dividend or things of that sort come in, and there are great reasons for that. And the Presbyterian Church has been behind the carbon initiatives for putting a price on carbon. And that's one of the things we need to do, and it's an economic thing. It works well in Europe. We don't have a model working for it in the US yet. But the other is, let's get back to thinking coral reefs, and I'll end on that point, is they're looking at things of what you can do to cool down reefs or to shade reefs and do things to help the corals because the temperatures are warm and we've got to take that edge off the really hot years. The Florida Keys, the people down there are wishing they'd been doing more on those kinds of systems for the last few years because they got caught flat-footed and didn't have any way to implement these quickly. Australia is experimenting with this. Since the 2016 and 2017 events, they put in a major fund experimenting with pulling cool water up and pumping it on the reef. You don't have to do that year-round. You only do it during the warmest time of the year, and you run those off solar panels, and it helps to cool reefs. On a little bit larger scale are these systems. On the upper left, or on the left side, you're actually looking at not something artificially done intentionally. Those are just simply the clouds that are produced by ship tracks off the U.S. Pacific Northwest. You have a ship, you have the fumes coming out of the exhaust going into the air, you get particulates, it makes clouds, and it does some shading. So they're experimenting on the right. The upper right is an artist's depiction, the lower right is an actual experiment going underway where they're taking these things that are basically like the snowmakers that you find on ski slopes to put salt water, just spray salt water into the air to try and make some of these clouds. We're talking about last-ditch efforts here. These are your real Hail Mary pass. What do you do when you're desperate? And we're at the desperate stage. Now, of course, for coral reefs, there are a lot of local stressors you can reduce. The lower image is showing erosion coming off the shore, and so better land use practices to keep from dumping fertilizer and sediment all over coral reefs. The upper right, there's still places in the world where blast fishing and other destructive fishing practices are taking a toll on not just the reef fish, but the very reef they live on. And so local practices are important and tie into this. And in fact, there's a story now of what's going on. Kiribati, which is this vast country, the width of the United States going across the Pacific, but little tiny islands with very few people living in the entire country. Some of the most magnificent reefs in the world, they lost 50 to 95% of their corals during the bleaching in 2016. They actually had continuous high heat stress conditions that lasted for over a year, and the impact was horrible. But if you look at what it's looking like now, that's a recent picture. It's been bouncing back. Why is it bouncing back? Well, it's this vast country that's about the width of the United States sitting in the middle of the Pacific with very few people. There are very few impacts that we're having. They banned fishing for anything except artisanal fishing around their islands. So there is very little fishing from other countries coming in, except pirate fishing that happens. The result is they've got all the fish there, they've got all the life there, they don't have the local stresses, and those corals are able to bounce back. But guess what? Most of the coral reefs are a lot closer to people, and we're not allowing them to bounce back during that time between events. So dealing with these local stressors is huge, and we need to be doing that to a great extent. And one of the things that's going on are these reef restoration programs. This has been the greatest success story in coral reef conservation, is going through and growing corals, mostly the fast-growing, easy corals. You can get a lot of coral out there, but they now have learned how to do it with some of the slower-growing corals. There are all kinds of ways of doing it, hanging them from strings, hanging them from little Christmas trees that are floating in the water, putting them on trays. There are any number of different ways it's done in different places, depending on what materials are available and the conditions. In Florida, you can get away with the little floating PVC Christmas trees. You stick those off Fiji, and they're going to be gone in one season because you're going to get a big storm. So there they use these big welded, metal things that look like a clothesline with coral strapped to the clothesline, and they tolerate typhoons. So, adapting to different techniques and putting them back out, it has done a great job on the reefs. But as we talked about in the Q&A yesterday, we're not cooling the water down, so the warm waters are going to come back again. So even if you put out corals that survived the last event and are able to tolerate a little bit higher temperatures, the temperatures are going up quicker than what we're seeing. But these are all great efforts. We need to be doing these because this is an all hands on deck kind of approach. So I'll tell one last little story. And this is what happened in 2015 in Hawaii. 2015, we were looking at forecasts. The forecasts on the left are the 60% and 90% probabilities of the heat stress that was going to be hitting Hawaii from the climate models, looking from July out to their main time when the bleaching would happen in around September, October timeframe. And as you can see, either one of those, it was showing a big hit for Hawaii. And if you look at the image over on the right, which was the maximum that was seen out there, the forecast did a pretty good job. There was one guy that I know out in Hawaii, works for the state, and when I was presenting this in a conference call to all of the people with the state DNR who work on corals, he was pushing back on it because he talked to one of the local experts and he said, you know, we've got these trade winds, they cause local upwelling, they keep the reefs cool. We just don't see bleaching like that here. I think the corals are going to get protected. And I said, Dave, I really hope that you're right and that the person you're talking to is right. That has worked in the past. And because I don't want to see this happen, but this is what the models are saying, and y'all make your decisions. What happened that year was the trade winds died. The trades just went flat. The waters warmed up. They had huge amounts of bleaching in Florida. I mean, it's in Hawaii. It was unlike anything they had ever seen in the main Hawaiian Islands. The good news is, while Dave had been thinking that was likely that the trade winds were going to keep them protected, he got a little scared, and he was now running a nursery where they were keeping corals that were being destroyed by construction and sudden things like that, bringing them into the nursery to protect them so they could then be used to replant in efforts where it was needed. And he thought, what we need to do, we've got all these endemic corals, these corals that are only found in Hawaii. And he said, we need to make sure we get them into the lab just in case. And so he issued a wanted poster, sent it around the state to all his contacts, the 12 most wanted corals. And normally the FBI did the 10 most wanted, but 3x4, it's a nice rectangle, so it worked well on there. There you see a bunch of them in the tank, and one of them circled there, Paraites duodenai, and that won't mean anything to you, but that's the one circled on the top line and circled in the tank down below. That species was wiped out completely in the wild in Hawaii. After the 2015 bleaching event, they could not find that coral in the wild at all. They went out to all the places they knew it existed. It was gone. It was dead. But they had it in the nursery. And using these new techniques that they've developed, people have developed called microfragmentation, where you can take little tiny pieces of coral, put them on a surface, let them grow up. They were able to grow that in the course of a couple of years, and you're looking at, and now I've forgotten the date, 2019. So that bleaching event was going on in the fall of 2015. This is June of 2019 on World Oceans Day, where they went out and they reintroduced that species back out in the wild to the same places they'd collected it from. To my knowledge, this is the fastest rewilding of a species that's ever been done. And the reason it happened was because the information was there from the forecast to go out and save that species and put it back out. It's just one species, there are a lot to deal with, but this is the kind of thing that can be done if we're aware of what's going on, we have the tools that we have, and we'll be having to do a lot more of this in the future if we don't deal with climate change. So the real issue is we've got to deal with the emissions from fossil fuels, cement production, deforestation, et cetera. So I'll just wrap up with a reminder about the film. For those who are online and haven't seen it, it won the Sundance Award when we premiered there, the Audience Award for Best U.S. Documentary. It won the 2018 Emmy for Best Nature Documentary, streaming on Netflix and on the Netflix YouTube's channel. And so for those of you who have already seen it, get some friends together and watch it again. Show it at your church. It's a great way to really demonstrate what's going on in the world, and it really brings the issue of climate change home in a way that the kind of charts and graphs that I show just don't do. It really brings it to heart, and that movie is a great one for that, which is the reason why I know I'm biased, but a lot of other people think it's a good movie too. So anyway, with that, Thank you very much. I'll close with this quote. This was an opinion article in the Washington Post earlier this year. I love this. The answer is not greater and greater attention to more and more crises. It is more time spent by each of us on the nurture of joy and the cultivation of hope. Which is, as the poet Emily Dickinson teaches us, the thing with feathers. We have to keep up our hope. I went through this event as we're going through the potential of more severe bleaching going on right now. We're looking at providing mental health assistance to coral reef experts around the world who are dealing with the ecosystems they love, dying before their eyes. Keeping that hope is essential because we don't have any other choice. We have to have hope. We have to keep working. And I hope you'll keep working too. Thanks.
Mark, I guess we have some time for questions.
Yes.
Before we open it up to, there is one question from the chat from Pam.
Great.
Who asked, Mark, what is the latest information on coral bleaching in Florida? Any idea about the ability of our reefs to recover?
Florida is in especially bad shape. They were bad before the recent bleaching events. There were diseases that wiped out a lot of the corals in Florida previously. It was then the big bleaching that happened, and then in recent years there was a disease that swept through called stony coral tissue loss disease. And if you want to talk about grief and really heart-wrenching experience, this is a disease that is affecting 60% of the corals in Florida. Almost all the types of corals are being hit by it or have been hit by it, some of them with anywhere from 50 to 90% mortality. So it's been devastating. And it took reefs that had already, because of a variety of local human factors and such, had been driven down to a tenth of the corals that were there to now having a tenth of that tenth. So reefs are in tough shape. That's why there are major efforts in restoration in Florida. But unfortunately, with the bleaching this year, a lot of the corals in those restoration efforts have died this year. And they're trying to figure out what to do next. I know I was pushing the coral program before I retired to, in addition, while you're doing this restoration, start experimenting with things for, rapid deployment of heating, cooling, shading. Not heating, cooling, shading, circulation, making currents, things of that sort to see what you can figure out. Because you're going to reach a point that these really valuable nurseries and these newly replanted corals are going to need protecting from an event. And I think they're probably going to be thinking a lot harder about it after this year. But I don't know what the totals are in terms of how much was lost this year, but I do know it was bad.
If we could get, I think, that piano microphone for people in the room. And then if we just, if you don't mind just taking, let's do an in-person question, and then I'll ask the question from online.
Great.
The coral that had just been planted, is that hardier than its predecessor?
The corals that they're using in the restoration activities generally are hardier, partly because they're being put through rougher conditions in some ways. They're also choosing some, and even trying to, there are programs, especially in Hawaii and Australia, where they're breeding more heat-resistant corals before putting them out. But the other problem is when you go out and you move them around and you take them out of the nurseries and you plant them, there's stress that's involved in that, so they're a bit stressed as well. So it's a mixed bag. In the long run, hopefully they're going to be more temperature resistant, but there are also some things that lead corals to, because of what goes on within the corals that allows them to become more heat resistant. If they're not being stressed, they may lose that tendency and go back.
But genetically, you're talking about the now extinct mess of that one coral and the little bit that was taken into the nursery, it was preserved, but is there anything that could be done while it's in that fragile development stage to make it hardier?
That's a whole other talk. There are efforts that are underway. But the people who started this program didn't like it when they started being called supercorals, and why not? We'll use the term. The whole idea of you're picking the ones that survive a heat stress event, you're crossbreeding those, you're putting them under stressful conditions. You're literally training them. It's like, you can have the best bloodlines in a racehorse, but if you don't train it well, it's going to be a slow horse. So the same thing. If you want these corals to be able to tolerate high heat, they actually torture them with high heat conditions. And so they're taking the ones that have better genetics and training them to be able to tolerate high heat. But this is a 10-year-old field. And so it's something that is a challenge, and people are racing against time.
There was a question online, if we want to just alternate back and forth, from Charmel, who asked, yes, if people put aquariums in homes to nurture corals, can that help save species or not enough?
Oh, that's an interesting question. It used to be that aquarium corals were a real problem because the way that they were harvested, and a lot of coral was destroyed in the process. Now, fortunately, especially in the U.S., most of the corals you get have been reared in aquaria. But the conditions are so different, and the corals that survive in aquarium situations often are not actually really well adapted to the wild any longer. And so home aquaria, I don't think, is going to provide much of a role. Now, there is a major role, and this is the important part. The ASCA, the American Society for Zoos and Aquaria, has been a major partner in these efforts. And I talked about the corals that were being pulled out of the water in the Florida Keys, put in containers and taken. A lot of those were going to public aquaria, to the research side of the big public aquaria, where they know how to deal with this and are isolating the corals, trying to protect them and so forth. So that is just as we are doing with species that are threatened on land. That's becoming a major way of dealing with these crises for corals as well. And so those professional aquarists are playing a major role in the conservation.
Usually the temperature and the acidity co-vary. And as you go more into the northern latitudes, you'll have a cooler temperature, but you'll still have the high acidity. How does that affect the corals?
So ocean acidification is much less of an impact than bleaching is. It'll cause them to grow slower, but growing slower versus being dead, that's a whole lot slower. The important thing, though, is that is an important factor that's coming into play. We're seeing waters that are more acidic, corals that are growing more slowly, and reefs that are eroding more rapidly. So the big effect of ocean acidification on corals is at the reef scale, not the individual coral scale, and it's having it's being a destructive force on reefs, so that there are a lot of reefs around the world now that are no longer building because of the acidity. They're actually in a net erosional state. And so that's the biggest impact that we're seeing. But those two do go together, and it's the rise in CO2 that's causing both of those.
There's an online question from Jim who asks, one, is there geologic history of bleaching? Is there geologic history events of bleaching? Then he asks, DNA tweaking to get heat tolerance? And then he finally asks, can polyps go dormant for later growth?
Polyps can't really go dormant. They need to stay active and alive, although what you'll have is perhaps in some bleaching events you may have live coral polyps on the bottom of branches or on the inside of colonies that can then later start working their way back out. It's a part of the recovery process. The DNA is a very complicated issue because you're dealing with actually As we now know, the microbiome is very important in our bodies. The microbiome is very important in corals, and we're not just talking about the algae. So you're talking about the genetics of the coral, the genetics of the algae, and the genetics of the various parts of the microbiome. And there's actually some work being done with probiotics and things to put on reefs to help them to recover. But it's a matter of scale. Those are small scale things that we are decade or more away from having answers to, and we've got very large scale bleaching going on. So it's a scaling and rate problem of us getting those discoveries underway. But again, all hands on deck. This is an important part that people are looking into and trying to deal with. The surprising thing that I hadn't realized, the genome of a coral isn't that far off from the genome of us size-wise. The genome of the algae is twice as large, and we know very little about either one of them. And so it makes that a very difficult process.
Okay, there are 3 questions from the the Zoom. I've got 3 quick questions, all sort of motivated by pictures that I saw.
Yeah.
The corals grow only in tropical zones, is that right?
Tropical to subtropical.
Subtropical?
These are the warm water corals we're talking about. There are other kinds of corals that are deep and cold corals, but they don't have the symbiotic
Okay.
algae and build
'Cause
reefs.
Your map
like this.
showing the threat showed this severe threat to corals from, say, Yukon Territory over to Siberia, but there aren't corals there, are there?
No.
Okay, that was just ocean warming.
That's what
Okay,
ocean
which is
warming.
gonna mess up fish, but there's no corals there to mess up.
Yeah.
Okay.
Actually, we have whale people who use
Sure.
those coral products because it helps them know some things that are going on with whales, which
Right.
seem really
They're
strange.
low
But
and
yeah.
readings. Okay. And second question about pictures. The new corals that were being planted in Florida they look like wind chimes hanging on strings. Are they suspended in water till they grow for a while, and then do they get released and go attached to
Yeah.
the rocks
So
below?
the strange thing that was discovered is the corals, those branching corals, will actually grow a whole lot faster if you suspend them in the water.
Really?
So they literally hang them like
Yeah.
Christmas tree ornaments.
Yeah.
That's why we refer to those as Christmas trees. But they grow very well, and then when they get larger, you either take the whole thing or you break off pieces of that and put them down and plant them on the bottom.
So they grow better if they're just in the water at
Mm-hmm.
first. Interesting. The third one, this is sort of image, but also basic bio. The algae that
Mm-hmm.
you said are essential, symbiotic. I mean, photosynthesis in plants, I mean, I'm only a philosopher. My bio was a long time ago. My understanding is photosynthesis helps plants derive energy, drives their metabolism.
Yep.
What good does the chlorophyll do to the corals? Do they gobble up the algae and get nutrition that way, or what's
No.
the good of the photosynthesis in the algae?
It's a symbiotic relationship. The algae are doing what plants do and growing and producing compounds, sugars and fatty acids and things that they then exude out through their cell walls to the coral, and are feeding the coral around them, and they get the protection of being able to live in this nice habitat inside an organism in a nice calm condition, and being fed nutrients that are the waste products of the coral. So it's a wonderful
So it's like each
relationship, but it's also one that's fairly fragile. When temperatures get too high, that's the relationship that breaks down that causes bleaching.
So it's like each organism is benefiting from the other's excretions.
Yeah, exactly.
Thanks.
There was an online question from Nancy who asks, what kind of mental health support is there for scientists, researchers? We all need this in some degree.
I have those resources. I don't know the name of them offhand. I think one of them is the Black Dog Program. There are a number. You could do some searches online for mental health and climate change. This is something that's been developing over time, and I could provide resources later on that.
So, last night in the film, you could clearly see the anguish of the photographers who were witnessing the incredible decline and so forth, and then the jolting impact on the scientists who are watching the report.
Yeah.
So, my question is for you, Mark, a personal one. Here you are, buoyant, positive, standing in front of us, wearing the right shirt with fish, and my God, it's amazing. the spirit giant of coral is right here. What is it that keeps you going? What sustains you in the middle of this incredibly worrisome emergency?
It was tough, and I didn't realize how bad it was until afterwards. But there were times that I would get emails, and I would literally just back myself away from my computer, walk over to the window, and look out at the trees. I fortunately had these windows that looked right into the trees between us and another set of buildings, and it's like, look down there, see if the groundhog's running around, see what birds are flying around, just get myself re-centered in the nature that was alive right behind me so I could turn around and face what was going on again. It is tough. It is very tough. It has been and this is one thing that's been realized, is the mental health effect of climate change on the scientific community, in biologists, ecologists like myself, oceanographers, terrestrial biologists, all the way to the people who are doing climate models, the realization of things. There are times that we get a forecast run comes out of the model, you look at it and you say, wow. Suddenly it hits you and shows you what's coming up. And this is the reason why the discussion has just started. I'm an officer in the International Coral Reef Society, and internationally we're working on identifying some of those resources that are available to help people out. Because we have, and as we did the last time, we have young scientists who are not at all prepared for this, and are facing it. And this is the reason that we need to realize that, yeah, there's a mental health challenge to this, and we need to be providing resources, pointing people in the direction of things that they can find to help. And that's all new. This is an entirely new field that's been happening as all of these things have been getting much tougher. But the important thing is, if anything else, my faith in God and the creator of all things we have around us, and the scientists' faith and hope in the ecosystems that they're working with, whether they're people of faith or not, is very important. And realizing that this is something we've got to be fighting for. And if like we were hearing with some of these big issues in the Matthew 25 discussions last night, in terms of racism, in terms of poverty, oh, it's so big, we can't do it. We started it. Those are all social constructs. We as humans created those situations as we're causing climate change. So guess what? We can do it. We can get rid of it too. We just have to work on it. Last question.
Back to the microalgae. The whole bleaching process is triggered when they stop functioning and they're expelled. I'm assuming that there's research someplace or other to get more, be able to introduce more hardy microalgae for the coral.
Been trying that. That's a lot harder than it seems. Some corals you can introduce new algae when they're adults. Some corals can't, as adults, accept algae that are not the ones that they didn't have when they were really young. It's an interesting situation. I mean, well, you're a physician, so you understand what goes on with the immune system. These corals have immune systems, but yet they've got these organisms inside them. So there's a system that's allowing them to recognize these foreign bodies as good. If you introduce a new one, is that going to work? And so sometimes it works, sometimes it doesn't. There are things that are being done to figure out ways to make that work, but it's a very complicated process that the more we come up with ideas that seem really good like that, when we get into it, it's like, ooh, that's a lot harder than we thought. But it is work that's still going on, and there's a lot of hope for that kind of work as a part of it. All right. I think we have to cut there. Thank you all very much.